Let's go through a review of significant figures, abbreviated sig figs. The number of sig figs in a quantity is an indication of how precise that quantity is. If we have a measurement of 170 meters per second, all that tells us is that the measurement was closer to 170 meters per second than it was to 160 or 180 meters per second. If we knew that it was 171 meters per second, then that's much more precise because we now know it's closer to 171 than it was to 170 or 172. Let's learn the sig fig rules. Here's the way you get the number of sig figs in a number when there is no decimal point. You start from the right and you move to the left. You skip over any trailing zeros until you come to the first number, and then you count all numbers after that. If we had the number 2000, we start from the right, count to the left, we skip all those trailing zeros, and we're left with one sig fig. So 2000 has only one sig fig. For 246,280, start from the right, skip that first zero, and then we have 5 left, so that's 5 sig figs. 26, there's no decimal place, so we start from the right. There's no zeros, so we just have those two numbers left. So 26 has 2 sig figs. 203,000, start from the right, skip those trailing zeros, and we're left with 3 numbers, and so that has 3 sig figs. When there is a decimal point present, then you start from the left and count from the right. Now you skip all leading zeros. So for example, if you have 0.000045, you start from the left because there's a decimal point present, count to the right, skip those leading zeros, there's 2 numbers left over, so there's 2 sig figs in this number. 286.5, start from the left, go to the right. There's no zeros to skip, so we have 4 numbers for sig figs, and so there's 4 sig figs. 0.02036, start from the left, go to the right, skip that first trailing zero, leading zero, and you have 4 numbers left over for 4 sig figs. A calculation should not add precision to the numbers that you have, the input numbers. If anything, it's going to take away precision. We need to have rules to know how to deal with the results of calculations. For multiplication and division, the answer should have the same number of sig figs as the least precise input to the calculation. So if you have 25 meters per second and you multiply by 0.5 seconds, you get 12.5 meters. 25 meters per second has 2 sig figs, and 0.5 has 1, so our answer needs to have 1 sig fig. So we'll round 12.5 down to 10, which has 1 sig fig, 10 meters. 365.7 meters divided by 2.6 seconds is 140.7 meters per second. 365.7 has 4 sig figs, and 2.6 has 2. So we'll need to round 140.7 to 140 meters per second. That has 2 sig figs. For addition and subtraction, it's less about the number of sig figs and more about the number of digits to the right of the decimal point. Your answer here should have the same number of digits to the right of the decimal point as the input with the least number of digits to the right of the decimal point. So I'll write that out here. For example, 1.5 plus 1.75 is equal to 3.25. 1.5 has 1 digit to the right of the decimal point. 1.75 has 2 digits to the right of the decimal point. So our answer should only have 1 digit to the right of the decimal point. So we round our answer to 3.3. 1.79 minus 1.74 is equal to 0.05. Both of these have 2 digits to the right of the decimal point. So does the answer. So this is correct. But here, notice that your inputs both have 3 sig figs, and your answer only has 1 sig fig. So this is a case where doing an operation with higher precision numbers can lead to a loss of precision. Let's talk about some good practice techniques. When you're doing your homework, quizzes, and tests, it's good practice to keep a couple of extra sig figs throughout your calculation. Then, at the end, round your answer using the calculation rules. This will keep you from rounding errors, but please do not write down more than 2 extra significant figures while you're doing calculations. Writing so many extra figures down is a waste of your time and does not affect the results of a calculation. Too many significant figures included in your calculations or the wrong number of significant figures at the end of your calculations can result in a loss of points. With Mastering Physics or whatever homework program you're using, you definitely want to wait to round until the end. Also, note that if you get an answer like 20 and you need 2 sig figs, there are a couple of ways to deal with that. One way is to write it in scientific notation. So in scientific notation, 20 is 2.0 times 10 to the 1 meters. That now has 2 significant figures. Colloquially, it is acceptable to write 20 with a decimal place at the end and no 0 afterwards to indicate 2 significant figures, but this is not the absolutely preferred method.